Okay, good morning. Welcome to
Number 657.
FamilyMath657. So we have some 3D printed rhombic dodecahedra, or dodecahedrons. I'm not even sure what the plural is. And we have our zone one we built yesterday. So my challenge problem to you guys today is to try to calculate the volume of these 3D printed ones.
Alright, and can we assume that the side length is just 1? Like this length here is 1.
Well, you can assume anything you want, but
Like, can we just say for like a rhombic dodecahedron that's side length 1?
what do you mean? The side length of
I mean,
the
like-
rhombic dodecahedron?
Or the side length of this. Like,
Okay.
this length is 1.
All right.
And we should find the volume of the whole shape.
Well, what would you do in that case?
Well, I would, say that it's like these two cubes, and try to find the side length of the cube, and then it would be twice the volume of one of the cubes.
Okay. What would you do to try to find the volume of our 3D printed rhombic dodecahedron?
Well, I would try to find, I would try to find this length here, sort of like repeated, and then I would either try to find the volume of one of these cubes or try to find the volume of one of these pyramids.
Okay. What do you think is easier, to find the volume of one of those pyramids or one of the cubes?
Cubes.
All right. How do you find the volume of a cube?
It's length. It's the length, the width, and the height. So
The side length cubed.
side length cubed.
Side length cubed. Okay. So
So-
the volume of a cube is side length cubed.
So
If we can just find the side length, we should be pretty good.
Which side length?
This side length of the cube.
Okay. How do you intend to do that?
Well, I'm going to use a little trick. I'm going to look at the pyramids. I'm going to make a right triangle that goes from this point down to the center of the face and over to this point right there.
Okay. So you would
I would
but
use,
we're trying to find the volume of these. Okay.
yeah.
So what are you going to do?
Well, once I find so I'm going to do that. And once I find this length, this height length, this is the diagonal of the cube, this is the height of the cube. Once I can find that, and this length here is half the side length of the cube. If I can find that, I'll know the length of the cube.
Okay.
This is half because once all the pyramids, if we turn all the pyramids inwards, they meet in the center. They'll all meet there.
Okay. What would you do to find the volume of this, of one of these?
So try to find the side length of one of these.
Okay.
So you could use, let's see. Well, I was thinking of using it'd be easy with right triangles, but
Well,
it's probably
again, we're trying to find what is the volume of this? Like, what is the answer going to be?
It's going to be twice the volume of the cube.
That might be right. That is right.
Well, it's going to be a number.
It's going to be some number.
Yeah.
Okay. In what do we want to measure it in? Meters cubed, millimeters cubed, centimeters cubed, inches cubed?
Units cubed.
Okay. So what do we need to do?
So we need to find the inside cube, and we need to double that. The
That's
volume
in the
of the
volume.
inside cube. We
Okay.
need to find the volume. We
All
double
right.
it.
Good. How are we going to do that?
To find the volume, we need to find the side length of the inside cubed.
Okay. How are we going to do that?
So I was going to use this little right triangle method.
Okay. But let's say you were going to use that. So let's say you
Right.
were going to do that. What would you do?
Well, I'm going to call this 1. Just say, well, I could call this one maybe. I don't know.
All right.
So
Let's go to the next move.